Chapter 6 explores concepts behind cloud computing. Let's first start talking about some basic networking ideas and then expand that to include the cloud. A network is basically two or more computing devices communicating with each other. These devices could be two computers, a computer and a printer, a tablet and a server, or a tablet and a computer. There are two main ways devices can connect to each other, using wired connections through Ethernet cables or using wireless connections through some Wi-Fi standard or Bluetooth. If you have devices connected around a single person, such as your smartphone and your headphones, or your laptop and your printer, then you have a personal area network. Usually PANs use Bluetooth to create these connections, but they can also use a wired or Wi-Fi connection. Bluetooth is useful in situations like this because it's meant for a relatively close connection. The range on Bluetooth devices is about 10 meters or 33 feet. Once you start connecting more devices, you start to develop a local area network. This is what you're probably familiar with if you have a cable or a DSL modem connected to a wireless router that ties your computers, gaming consoles, and mobile devices to the internet. In a business setting, you may have many different devices connected to each other with switches or hubs, and you may have different connections on different floors or different buildings. This is still a LAN. Even though some of the computers are in different buildings, as long as they're still under control of a local network administrator, it's still a LAN. In most business cases, devices on a LAN have a client-server relationship. Client computers, sometimes called workstations, are where most employees work, and servers are computers that control data flow. Some servers control incoming and outgoing email, other servers control print jobs for multiple printers, and still other servers are storage repositories. Most home networks are peer-to-peer networks. In these kind of networks, there is no control center for data. A computer can share a file directly with a tablet or can stream music or videos directly to a smart TV. For that instance where one device is controlling data flow, you have an instantaneous client-server relationship, but it's not a permanent relationship as it is with a traditional client-server arrangement. All devices in a peer-to-peer network can serve as a client or as a server at any given moment. A wide area network consists of different LANs. If you have a business with multiple locations, maybe there are offices at different physical addresses or different cities, those networks can still share data if they're connected through a WAN. When you connect different locations, you're more than likely relying on an internet service provider to make that connection for you. Instead of a client-server LAN, where a workstation can access data on a server through its Ethernet cabling, in a WAN, a workstation may have to access a remote server using an internet connection. Some larger businesses may have dedicated wired connections between their locations using copper-based or fiber optic cabling, and others may use a point-to-point wireless or satellite connection. But because of the cost savings, most use ISPs to facilitate the connection. The internet is the connection of other networks together. It's essentially a network of networks. The internet is inherently not secure. Data that flows on the internet isn't always encrypted, and because the internet is publicly accessible, anyone can see the data, encrypted or not, if they have the right tools. This could be a problem for some businesses that have sensitive data. That's why some businesses spend the money on a direct connection between sites. No one would be able to see their data if they control the pathway. Other businesses opt for a virtual private network. A VPN creates a tunnel between two locations so that no one else can see data that flows in the tunnel. A VPN still uses the public internet for the physical connections, but software joins the two ends and makes it look like the two separate networks are actually one network, hence the virtual part of VPN. You may be familiar with personal VPNs from gaming or general internet surfing. The concept is the same. When you connect to a VPN, you become part of that network virtually, even though physically you're not in the same location. Deployed military members take advantage of this. They may be overseas, but if they connect to a US-based VPN, everything they access, such as Netflix or Hulu, thinks that they're in the US and will thus show them US-based programming. This is a great way of hiding what you're doing. If you connect to a foreign VPN, then whatever you're doing will look like you're in that country and not where you physically are. Remote users may be able to access their company's servers through a VPN in the same way. If an employee connects to a corporate VPN, they become part of that network and can access anything that they normally would as if they were physically at the office. This can get confusing or amusing depending on your point of view. For example, if you're connected to a VPN and you print a document, that might print at the office instead of at home because the network thinks you're in the office and not at home. This brings us back to the idea behind cloud computing. A cloud service provider is essentially a LAN that other people can use for a fee. Business users can rent or lease a server, which is infrastructure as a service. With IaaS, end users will need to provide their own operating system and applications. Users can also rent or lease a server, an operating system, and some software like a DBMS, which is Platform as a Service. In this case, business users only need to provide the software they want to use. If a cloud service provider offers everything, the server, the operating system, and applications, then that is called Software as a Service. And in this case, business users don't have to worry about anything. With each of these options, business users still have to maintain an internet connection to the provider. It doesn't have to be a persistent connection in all cases, but it should be a reliable one. But if your internet service provider has an outage, then you won't be able to access anything on the provider's hardware. Also, relying on a cloud services provider for mission-critical applications can be a problem if that provider experiences outages. On the other hand, going with a cloud service makes sense for some businesses. If you don't have the IT expertise or don't want to deal with setting up and maintaining a server, then having someone else do it may save you time, headache, and money. It should be noted that cloud service providers don't necessarily have a server for each client they have. Through virtualization, they may be able to take one physical server and create 20 virtual servers for different clients. They can also increase and decrease capacity on the fly based on demand. A client may need more processing power and storage based on an expected influx of orders or because of seasonal demand. What's the right option? It depends on the business's technical savvy, budget, the type of business they're in, and how controlling they are about the data. And that's Chapter 6.